Welcome to another installment of Data Skeptic Animal Intelligence. Today we're talking about a new, well, not so new, but a relatively new corpus of images for a computer vision problem, specifically around animal tracks. Becky, did you have any insights or expectations going into this one?
I was impressed because this is a really challenging kind of data set to look at. This isn't like iNaturalist where we know what species exist here, what color they are, what patterns. You're basically looking at really noisy images in different substrates with no scale bars. So to me, that was very impressive that they were getting some cool results and able to identify tracks.
Yeah, it's a database of animal tracks, which is a really interesting problem because, picture one in your mind. It isn't like a 3D contour laser scan. It's something that went into a medium like mud that has its own, physical properties that can make this an interesting and challenging problem, not to mention that two paws can easily look alike from very similar yet distinct species.
Absolutely. It just seems like a very noisy data set to me. So definitely pretty cool. And I was really interested in the conversation that you and Risa were having about how humans identify tracks and how that might be similar or dissimilar to any kind of machine learning AI sort of mechanism.
Well, it's great that not to spoil it, but they use attention maps in the work a little bit, which is a nice machine learning tool for getting an understanding like a heat map to say, what is my model considering? So in the case of tracks, if it's looking at, the contours and maybe the specific, size of the paw or something like that, you would trust that it's doing a good job. If it's looking at artifacts in the image that aren't part of the track, you would know you've overfit in some way. So a nice little interpretability tool there for everyone.
Yeah, and I kind of wonder how similar that might be to what people are doing, because it made me think of biologists that are very good at identifying very similar looking species. Animal tracks would also fit in this. That once you get really good at your handful of species or whatever you're looking at, it becomes difficult to describe to another person what you're seeing that's different, to tell them apart. And to me, I'm like, I guess people can be black boxes too, because we don't always know what information our models are using to identify things.
Very good analogy.
So your conversation about that really struck me.
Well, I've got one other bit of trivia I wanted to squeeze in here. Do you know the name Grover Krantz?
The name Krantz rings a bell.
All right. This was a long shot. He is, if you can call anyone this, the academic authority on Bigfoot. He's one of the only guys who kind of came from academia and took it seriously. Wrote a book that I read a few years ago. I found it unconvincing, but his point I was reminded of, he's convinced that he found dermal ridges in some of his Bigfoot footprints. That somehow, out there in the mud and against the elements, he was still able to capture actual footprint or the equivalent of toe prints, fingerprints in these casts he took.
I suppose you could figure that out if you had the cast to verify it. And I think I maybe know why his name is familiar to me. So my master's and undergraduate degree was at Idaho State University, and there's another anthropologist researcher named Dr. Jeff Meldrum.
Oh, I know Meldrum too, yeah.
Yeah, who also studies this stuff.
Yep.
In my experience, he's more likely than many others to go, I don't know what that track is. But similar kind of thing. Yeah, that's interesting. I'm trying to think if you could really get ridges off a plaster cast, and I'm not sure.
Yeah, good question. Does seem a little dubious, but even if you can, not evidence of Bigfoot.
Yeah, exactly. I would still need a lot more.
Definitely. Well, let's learn what we can find interesting about tracks in today's interview.
I'm Risa Shinoda. I'm a PhD student at Kyoto University. I'm specializing in agricultural engineering in Kyoto University. So my work primarily involves applying computer vision techniques to agricultural crops there.
And when did computer vision start having an impact in agriculture?
Yes, exactly. Agriculture is traditional task, but recently computer vision techniques has been developed, and a lot of stuff can do automatically by the AI. So it's challenging task, but it's new task, and it's fun to explore.
Well, you could certainly get a PhD only studying computer vision. Could you share some details about what you had to study on the agricultural engineering side to do your work?
So I'm doing applying computer vision techniques to agriculture crop, and besides, I've expanded my focus to include AI for animal conservation recently. So this stuff is very important for things like improving animal welfare and preserving biodiversity. And I'm also really into the field of computer vision too. Through the internships, I've been able to learn about computer vision algorithm and stay updated with the latest computer vision trends there. So like my projects have included working with synthesized images and vision language there. So I'm into both using computer vision for agriculture and animal stuff, as well as pure tech part of computer vision.
Do you have a sense of what breakthroughs, or maybe series of breakthroughs, made it possible to bring computer vision into agriculture?
So the key technique is autonomous agriculture. People call it smart agriculture. Especially in Japan, we do farming in a small land, and also like people dedicated to agriculture tend to be more involves more elder people, not like young people. So like assist for their body damage is very important. So we explore to how to automate the really heavy stuff in the agriculture, like the picking crops or people picking crops one by one recently. So we automate that kind of steps.
Well, I first came across your work when I found the OpenAnimalTracks paper and its accompanying data set. Could you share some details on what the data set is?
Okay, so OpenAnimalTracks you mentioned is the first publicly available level dataset designed to facilitate the automated classification and detection of animal footprints. So it contains various footprints from 18 wild animal species. While most datasets focus on detecting animal species directly, but in real world scenarios, counting all animals or monitoring land is very challenging. So therefore, people engage in animal tracking, which involves identifying animals by their traces. And there, one big clue is animal footprints.
Could you give us some details on the data set, like approximately how many images and how many classes?
Okay, so we include 18 classes there. The images is around 4,000 for classification and 2,500 for detection.
And could you share, obviously, we're not going to go through every species, but give listeners some understanding of what types of footprints or what types of animals you have in the data set?
Okay, I have wants to include a lot of animal species as much as possible, but it's very hard to collect all of animal footprints. Like people don't usually take the photos of them. Basically, we collect major animals like bear, beaver, cat, the elephant, or something like that. It covers a lot of typical animal footprints you can encounter.
A snowball starts off as no big deal, but let it roll, gain speed, and gather size, and soon it becomes an avalanche capable of wiping out your entire camp. The same goes for social engineering attacks, where a single user's mistake can put your whole organization at risk. This October, let Arctic Wolf be your guide to surviving the social engineering avalanche. Register now for the 2024 Arctic Wolf Security Awareness Summit, where we'll outfit you with the information and insights you need to fill your social engineering survival kit, offer tips, tools, and takeaways to keep your security awareness top of mind all year long, and show you a better path past the hazards of human risk. Register now at arcticwolf.com/register. This is worth going to. I'm going to sign up. That's arcticwolf.com/register.
Thanks to our sponsor, the Georgia Tech Scheller College of Business. Check them out at techgradcertificates.com, especially if you're ready to become a data-savvy leader. Did you know the Georgia Tech Scheller College of Business is ranked a top 10 business school in the U.S. for business analytics? They offer a 100% online business analytics graduate certificate program. There's 4 courses covered: business analytics for managers, machine learning for business data preparation and visualization, and analysis of unstructured data. This graduate certificate is designed for professionals in any industry that want to become data-savvy leaders or just pivot into analytics. You can maintain a work-life balance and other commitments while going through this flexible graduate certificate program at your own pace. And that certificate can be your gateway to a Georgia Tech MBA. So if you want to stay ahead of the game and learn key strategies to extract information from the vast amounts of data generated every day in business, consider pursuing this certificate. Applications are open for the fall of 2024. Get started at techgradcertificates.com. And are these footprints you had to go out and photograph, or did you collect these from various places?
I'm not collect by myself. I conduct a lot of expertise about the animal footprints, and I collect them by them.
And what types of people are interested in animal footprints?
I feel like I want to contribute people engaged in wildlife conservation. So surveying ecology is an important aspect of land development and also animal conservation, and animal footprints can be essential clue to understanding animal ecology there. Additionally, during my research on this dataset, I've noticed that some people are curious about the footprints near their homes and often upload images to social media and asking what animal is this footprint. So I believe that this tool can interest not only experts, I feel like, but also people who are passionate about animals and the environment may be interested.
The data sets for research purposes, I think, would a researcher find the photos to be well cropped, or do they have to maybe go and locate the track or one track of mini in an image?
We already offer the cropped image around their footprints, and also we provide the raw images, but it's annotated already, so like people just can use our dataset.
Well, I think I can tell the difference between a bear and a duck pretty well, but I'm looking at some of the images in the paper and like a coyote and a fox, my eyes are not trained good enough to tell the difference. Can experts tell the difference? Human experts, can they tell the difference?
Surprisingly, they can. Maybe sometimes they also see the location and also like size of a footprints. I mean, I don't label the size of footprints in my images. So like maybe telling this kind of photo is difficult for us, but the experts say they can tell.
So you have a classic machine learning problem then in computer vision. You have labeled image data, and you'd like to be able to predict from a new image what is the species of the track you're seeing. What are the methodologies or algorithms you use in that effort?
So yeah, we have established two benchmark tasks. So one is classification, and the second one is detection. For classification, once we assign rectangular bounding box around the footprints, we extract data within the bounding box to create the classification dataset. And the detection dataset involves detecting and identifying animal species directly from raw images. So like we just employ multiple state-of-the-art sort of models, and it's very standard models for these tasks. For example, classification, we use VGZ ResNet, EfficientNet, VIT, and Swing Transformer. And for detection, we employ FASTA, RCNN, SSD, and YOLO.
So does that mean you're using some transfer learning as well, or is it trained from scratch?
We use the emergent pre-training model.
Got it. Yep. And then how do you evaluate the quality of your model?
For classification tasks, we use just accuracy to see how well the model performs. And for detection, we use some called MAP. It's called mean average precision. So it's a common way to measure how good the model is at detecting objects. So like basically MAP looks at how precise the model is across different categories and how well it can identify the location of these footprints are in the images.
And then what sort of, maybe we could talk a little bit about numbers because that's interesting, but it's not as interesting to know it's 70 or 78% accurate or that sort of thing. My bigger question is, do you think it's a good accuracy you're getting currently?
Yeah, actually, the accuracy is much better than I expected, especially because some species are tough to distinguish even for humans. So for classification, we are hitting around 70% accuracy. So it's considering like we are dealing with 18 different species. So it shows the model is really picking up on the unique traits on the footprint. When I visualize the attention map of the vision transformer, it's clear the model is focusing on the key features of the footprint shapes.
Aha. And do you have a sense of how it performs compared to a human expert?
I think the expert I contacted can distinguish more. They see a lot of footprints in their lifetime. So like maybe our datasets amount of our dataset is maybe much less than the image he saw in his lifetime. So maybe that's why that's one of the reasons.
That makes sense, yeah. So more data would certainly be helpful to make your accuracy improve. Do you think there are other things, like would you want to explore better algorithms or maybe higher quality data?
I really think that having more data is the most important thing in our benchmark, I guess. Earlier, our dataset involves classes that are hard to distinguish and covers a very specific topic like identifying footprints. So the model definitely needs a lot of data to run effectively. And also, I believe our dataset quality is already high because we are not just randomly Googling images. So we are collecting them properly by expertise. There might also be some room to improve the algorithm part to better specialize in recognized footprints, but honestly, I believe the amount of data is the most essential factor.
And as I'm looking at some of the images from your paper, to my eyes, the horseshoe stands out very clearly. I would imagine
Mhm.
maybe you get a good accuracy on that. Are there any other classes that you notice it gets a little bit confused on? Where is the model weakest?
So we've noticed that some species tends to get mixed up with others. I mean, that looks similar. So, for example, coyotes are often mistaken for foxes, and mice are frequently misclassified as minks. So, these mistakes usually happen with species that are genetically close to each other. So, it shows us there's definitely room to improve our model like these kind of species.
Right, but the same mistakes I think a human would make. It's just kind of interesting.
Yeah, yeah, yeah.
Do you find that different textures or environments affect the model? I'm thinking of like a footprint in mud versus sand versus snow. Do those affect the quality of the model?
Actually, in our paper, we don't use texture information to train the model right now, but we've labeled the texture for potential future research. If we start using the texture label during training, maybe we could potentially develop a model that isn't easily swayed by the background textures. So maybe this would help the model focus more distinguishing footprints, which could be promising detection for future improvements.
Do you have a sense of the future of the data set? Is this kind of a completed project or is it ongoing work?
Actually, it's ongoing work. So I collect more images than this and already labeled a little bit.
Could you talk a little bit about the collaboration? I know other researchers can apply to get a copy of the data set for research purposes. Have you seen any interesting collaborations or uses come out of that?
Yeah, actually, this paper is just came out, so I've not seen yet. So I hope I will see a lot of interesting collaboration of this dataset in near future.
Yeah, I think there's a neat opportunity there. Do you think it's also potentially an area for people interested in algorithms to explore? I don't, obviously you're using a transformer, but maybe something new could come along, someone could apply.
Yeah, I might think so. Like, the distribution of the images is very different to our dataset, so each class is very hard to distinguish. So, like, maybe the people who worked in the domain adaptation or classification detection, I'm not sure, but maybe this hard type of dataset is maybe very interesting to those people who are working on.
Obviously, this is part of your work. Could you share a few details on other projects you're involved in?
Okay, thank you. So I just published a paper called Pet Face, where we've taken on the challenges of identifying animals by their faces. So this time it's not about telling different species apart, but recognizing individual animals. So it's a very cool area to explore because dogs, for example, maybe dogs know each other by their smell, not by what they look like. So trying to identify them by their faces is completely different challenges compared to humans who rely on visual cues. And we got some strong results there. This approach could be less invasive way to identify animals, way better than methods like toe clipping or tattoos, especially for animals in labs.
Interesting. So, this may be my human bias, but I find humans to have pretty unique faces. I can tell people apart
Mm-hmm.
just by their face.
Yeah.
I can't do that with dogs, but of course, I'm not a dog, so maybe the expectation is too high. Is it truly that they're a little bit more common to each other?
Yeah. For us, like some people who own dog says, telling the dog faces by within the same breeds is very difficult. But I also conduct some identifying dogs within the same species like Chihuahua or Dachshund or something. And actually, it hits around 100% accuracy for the identifying animals. So yeah, actually, it's gets some stronger results than expected.
And can the attention map technique that you use to analyze the tracks in the research paper, can you apply that same technique to get some understanding of what features the vision transformer is relying on?
Actually, we don't conduct it yet, but yeah, that's also the interesting aspects for the, also biologists maybe, like we can analyze the potential part of the animal faces, which can make differences between individuals. Yeah, that's very good aspect.
And is there anywhere listeners can follow you online?
There are Twitter accounts, and also I have a homepage. Yeah, you can mail me or DM me if you have interest in my research.
Sounds good. We'll have links to all the above in the show notes for people to follow up.
Mm-hmm.
Risa, thank you so much for taking the time to come on and share your work.
Yeah, thank you so much.